This is a production of Cornell University.
I'm very pleased to introduce Dr. Suzanne Snedeker. She's the Associate Director for Translational Research for BSurf at Cornell. After earning her bachelor's degree at Cornell University and her doctoral degree in nutritional sciences at the University of Wisconsin-Madison, she taught nutritional biochemistry and research methods at the University of Texas Health Science Center. In North Carolina, she completed several postdoctoral fellowships at the National Institute for Environmental Health Sciences, and then worked as a biologist at the National Toxicology Program. There she evaluated the effect of endocrine disrupting environmental chemicals on reproduction and the incidence of cancer using laboratory animal models. Suzanne's responsibility at BSurf include writing evaluations of the scientific literature and on the relationship of environmental chemicals to cancer risk, developing web-based modules and databases on environmental chemicals and cancer risk, writing commentaries on research on cancer and the environment for the BSurf newsletter and for cancer survivor, environmental, and agricultural publications. She gives presentations and workshops on environmental factors and cancer risk, and also serves on state and federal advisory panels as a cancer and environmental expert.
Thank you. Thank you, Ed. We're here to talk about breast cancer and the estrogen connection, and very specifically the role of estrogenic chemicals in everyday products found in plastics, cosmetics and personal care products, and even electronics. But I thought first we could go back just a little bit to where was BSurf when it began, which was 1995. And every answer has to begin with a question. And the cancer advocates on Long Island asked, what role do environmental chemicals play in breast cancer? And they asked that of then Senator Alphonse D'Amato, who asked then the newly brought in President Hunter Rawlings, who asked our first director, June Fessenden McDonald, who then asked the director of the toxicology program, Dr. Rod Dietert, who was our second director, who then asked me, because I had just moved to town from North Carolina, and I had experience in toxicology, cancer biology, and endocrine disrupting chemicals. And from the very beginning of our program, we've always talked about the role the hormone estrogen has in breast cancer risk, both the estrogen made by a woman's ovaries, estrogen that's got converted from body fat, body fat that gets converted to estrogen, and estrogen from synthetic chemicals. When our program started, we talked, and we still do a lot of programming on pesticides, but we've really switched our focus to really concentrate on the estrogenic chemicals just because of all the new data that has been arising, especially in the last 18 months. So for those of you that have not come to one of our cancer forums, I did want to give you a flavor about what BSurf is about. And we are both a research and a public health outreach program providing the very best current science on what's known about environmental risk factors that affect the risk of breast cancer and other factors. And if you had to use 5 words to describe us, it would first be evaluate the most current science. We translate it to make sense out of the science. We partner with targeted audiences, and many of our partners, I'm pleased to say, are in this room and have been working with us for our 14 years. And this is one of our forums, is one of the ways we try to educate people on what's known about these factors and how to reduce cancer risk. And finally, we try to evaluate our outreach efforts, and that's another reminder for why the evaluation form is so important for you to fill out today. The focus of the Estrogen Connection project, again, is on chemicals in everyday products. And we started this project with a very different target audience. the target audience was for young women. And we chose young women, especially high school and college age women, because they're at the age in their lives when they're making fundamental changes in their lives and they're adopting lifestyle practices that they likely will carry with them their entire lives. So we developed, in collaboration with a wonderful unit we have in our college, a video production unit headed by Dr. Jody Korich that has talented videographers as well as animators. 3 videos on these topics, on plastics, cosmetics, and what goes in the dump and down the drain. And we've tried to widely broadcast these really short videos. They're 3 to 4 minutes long. And we are going to be showing these videos later tonight, right after dinner, and talking about them even more. We also not only have them on our website, we put them on Cornell's video site and also on YouTube. And when we started this project, I didn't even know that YouTube, I thought it was a capital U-T-U-B-E. I had never gone on YouTube before, and I had never gone on iTunes till a couple of weeks ago, and they are actually also on iTunes. So it's been an experience for those of us that are over 50 and in our perimenopausal years to come against how Generation Y communicates. But indeed, we have been doing that all summer long. The videos get released in May, and this is a clip of a picture they took of me with one of the water bottles over there. This is my own, that's sitting on the counter here. On telling young women what they can do to reduce their exposure to environmental chemicals. We started partnering with our target group, so we talked to students. We talked to all the students that worked for BSurf, and we did focus groups with 2 groups of college students that were at Ithaca College. And we found they really had a really scant knowledge of breast cancer risk factors and cancer risk factors in general, other than smoking and lung cancer, and a bit on sun exposure and skin cancer. They really couldn't name any breast cancer risk factors. So we really found a very low level of knowledge. We asked them how do they receive and share information, and it was unanimous. It was via YouTube. We originally, when we wrote the grant for this project, said we wanted to do iTunes podcasts, which we ultimately have, but even in 1 year's time, the whole culture changed, and all the students communicated by YouTube. And we asked them about things we were thinking of putting in the video. What things would they be receptive of? Because there are a lot of different chemicals that are environmental estrogen, but obviously with short videos and attention span and trying to get clear messages across, we could only pick a few. And they told us a few things. They said, keep it short, and 2 to 3 minutes is considered a long time for YouTube and college students. To me, if you know me and how long I talk, it's like the greatest challenge I've had is try to write, a 2 or 3 minute script. Keep it really simple. What can I easily do? What little changes can I make in my life? Make it relevant. It has to be things that I encounter all the time. Give me the facts and don't give me the science. Which also is a very difficult thing for me to do for those of you who know me or don't give me very much science, but we really decided we had to do a combination. So I'm going to talk a little bit about the science behind why we did the videos first before we talk about the 3 factors. And many of you have seen this slide before. It illustrates the vast complexity of breast cancer. And this is depicting breast cancer risk factors as puzzle pieces. And the analogy is true too. There's much about breast cancer risk that we know, much that's emerging. A lot of it does fit together. And some factors have been consistently well studied, and other factors are emerging and are still under investigation. And we do know that a lot of breast cancer risk factors that have been discussed by previous speakers increase breast cancer risk, like getting older and being a woman, having your period early, menarche late, that defines your reproductive years, having your first child late or not at all, and having a close relative with breast cancer. And why that does, for those women that do have a first-degree relative with breast cancer risk, as the last speaker illustrated, does increase your risk. The reality is that 80% of all women diagnosed with breast cancer do not have a first-degree relative with the disease. So the majority, and that was the biggest surprise for the college students, because everyone thought, well, if I don't have a relative, I'm home free, I don't have to worry about breast cancer. But indeed, studies with twins in Scandinavia have shown that the majority of breast cancer risk is not inherited factors. Those with inherited factors have a higher risk, but most of breast cancer risk, about 3/4 of breast cancer risk, is probably attributable to things that aren't inherited. And that is called environmental, environment being fairly broad, whether it be lifestyle factors, dietary factors, or environmental chemicals. In today's talk, we're specifically focusing on the role of chemicals and the role of estrogen and estrogen from environmental chemicals. Why study estrogen? What's the connection? Well, if you look at all those breast cancer risk factors and you pull out the ones that have something to do with estrogen, you actually have half of the risk factors are now on this slide. And every one of these risk factors is tied to exposure to the hormone estrogen, either made by your body or to synthetic forms. We know that, again, menarche and menopause define the reproductive years, and the more menstrual cycle a woman has, the higher her breast cancer risk. With every menstrual cycle, you are exposed to cyclic estrogens that go up, as well as to another hormone, progesterone, which also affects breast cancer risk. With lack of exercise, you have shorter menstrual cycles and greater number of periods, and therefore a greater number of cycles of being exposed to estrogen. Alcohol affects how estrogen in your body is metabolized. Especially risk is increased with more than 2 drinks a day, and alcohol makes your body keep estrogen in the blood for a longer period of time. It doesn't break it down as readily. Current hormone therapy, whether it be oral contraceptive agents or hormone replacement therapy, does slightly to moderately increase breast cancer risk while those pharmaceuticals are being taken. When they're discontinued, risk drops within 5 to 10 years. But in postmenopausally, you can convert body fat to estrogen. So women, especially that gain weight in their perimenopausal years, 40 to 50, and postmenopausally that are obese, have a higher breast cancer risk than leaner women. We're going to focus specifically on chemicals because of the concern of how environmental chemicals might also be contributing to breast cancer risk. So the biology and why there is concern is because we know estrogen, while it's very important for normal breast development, it also has a role in the cancer process. We know that women that have higher levels of blood estrogen have a higher risk of breast cancer, and that's been found in a number of studies and a number of meta-analyses where the epidemiological studies are looked at together. We also know that most women with breast cancer do not have a family history of the disease yet. Most of the women diagnosed with breast cancer, over 78%, have breast tumors that have the estrogen receptor. And the estrogen receptor is how the body communicates with the estrogen. And indeed, these tumors depend on estrogen to grow. So that's the biology. So that's one part of why we wanted to go forward with this project. The other part is exposure. We know that we're exposed to a wide number of everyday products that either contain or release environmental chemicals. The other really big change have been studies, especially in the last 18 months, released by the Centers for Disease Control and Prevention, the CDC. Some of you may know that they have a biomonitoring program that's been going on for a number of years. And interim of publishing their big reports, their last big one was published in 2005, they've been publishing papers. And several of the papers they published in the last several years have looked at urinary levels of environmental estrogens. And for a number that are in our videos, they have found that sometimes between over 90% of the samples they did detect environmental estrogens in the urine in the general population of Americans. So this isn't a high-risk population. This is just taking about 2,500 samples from the general population in the U.S. and seeing that there is detectable environmental estrogens. The other part that really inspired us, a year ago, just over a year ago, we invited Dr. Andreas Kortenkamp, who's at the London School of Pharmacy, to do our cancer forum in New York City. And he presented a really elegant talk on his work on mixtures, and specifically his work that models how estrogens, even at very, very low levels, may work together to give an estrogenic response and may work with the body's own estrogen to increase breast cancer risk. Last summer, his papers were published, a series of them, in the journal you might have heard of, Environmental Health Perspectives. And so we have solid evidence for a model that low levels of environmental estrogens at the levels we are exposed to can work together to have an estrogenic response. And we feel that this evidence also tells us that we do have to be concerned about contribution to breast cancer risk. We also know from other large studies, like the Nurses' Health Study, that indeed higher levels of estrogen does contribute to breast cancer risk. And also another study, the Endogenous Hormone and Breast Cancer Collaborative Group, did a reanalysis of 9 prospective studies and also showed that breast cancer risk, especially postmenopausal breast cancer risk, was associated with higher levels of estrogen. Well, how do hormones work? They're chemical messengers made in one tissue, affect another tissue, breast tissue being one of the tissues being affected. So during a woman's reproductive years, estrogen is made in the ovaries, but can act on the breast. And what's the message it gives? The message it gives is for breast cells to divide. What happens when a breast cell divides? When any cell divides, it's going to make a copy of its DNA. So each daughter cell has an exact copy of DNA. Whenever cells divide and whenever they have to replicate, there's a chance of making a mistake. And those mistakes in the genetic code, you saw the A, T's, G's, and C's out there before. Either a rearrangement or a deletion or an addition in that code is called a mutation. And so that is what is of concern. So hormones work through receptors, and for estrogens is important because they work similar to a lock and key mechanism. The estrogen receptor is in the target tissue, and it can be thought of as the lock, and estrogen as the key. And it's kind of like your car's ignition. It would be as if all of you had a key to my car, and all of you could start my car. Because estrogen receptor doesn't just recognize the estrogen that your body makes in the ovaries. It recognizes any other like chemical substance that can also fit into the lock and turn on the ignition. And in the same way, your ignition makes a whole series of events happen. And you don't know, I don't know what's going on under the hood. I just know that the initiating event is turning on the key. A cancer cell is like a car where the ignition is on, the brake pedal does not exist, and the car has the accelerator floored. The cell can't stop dividing, and it has no sets of checks and balances. So the estrogen receptor is very promiscuous, and I've given some talk to sororities, and they can relate to this when I say, well, the estrogen receptor is promiscuous. It is like a lady of the evening. It will have many dance partners. So that is why we're concerned about environmental estrogens. Even though they're weaker, they are much weaker than the estrogen our body makes. We're concerned because they do have the capacity to bind to the estrogen receptor and to turn on these events and contribute to the cell division and mutations. Most people don't know what the inside of a breast looks like, and I talk about that too when I talk to the sorority girls. You think of the rounded shape of the breast, but you don't realize that the breast ducts actually look like broccoli. That's what it most looks like. It's a highly branched structure, and if you can think of all those little flowerets on broccoli making milk, that is very much what the structure of the breast looks like, and this was drawn by an animator. So if you look at these tubes that are connected and you slice a tube, what you get is a tube, and you have breast cells that are lining that tube. Well, the process of cancer is a very long one. So you can have an initiated cell with a mutation, but the process of going from an initiated cell to gradually cells dividing more and turning into cancer cells and then metastasizing and invading other tissues is probably a process that takes 10 to maybe 50 years. So it is a very long process, and it's very gradual changes in key genes that control the ability of the cell to divide and the ability of the cell to die, because cancer cells are not dying the way normal cells do die. So in invasive breast cancer, most of the breast tumors do have estrogen receptor, and indeed the basis of many treatment drugs are to either stop the estrogen receptor from working or to stop making estrogen by using aromatase inhibitors, so stopping estrogen synthesis. We can learn lessons from estrogenic pharmaceuticals, from diethylstilbestrol, but only now, in the last 2 years, do we even have any data from the DES daughters. We have had to wait this long for the epidemiology, over 30 years for the DES daughters to get to the age where you see an increase in breast cancer risk over the age of 40. And we do know that both mothers and daughters exposed to the non-steroidal estrogen, diethylstilbestrol, have a higher breast cancer risk, a moderate increase of about 25%. With oral contraceptive agents, especially those that are older, that had higher levels of estrogen, we're seeing around a 25% increase in risk. The more recent ones, somewhat lower risk. In hormone replacement therapy, the majority of studies did see, especially the combined use of estrogen and progesterone replacement therapies, did increase breast cancer risk. It was mentioned one of the only times we've seen a drop in breast cancer risk is when about half of the women taking hormone replacement therapy decided not to take it. Hormone replacement therapy was prescribed to 20 million women in this country. 10 million women decided not to take it anymore. And over several years, we saw a 6% decrease in breast cancer. And we really have very little explanation other than this for that drop. So the work from Dr. Kortenkamp's lab suggested, so many researchers said it really doesn't matter, the estrogen's at too low a level, it's not relevant. But his research was key to look at mixtures. That the key part of it is not looking at estrogenic chemicals individually, but looking at them together, because that is how we're exposed to estrogenic chemicals. We don't get exposed to one thing today and something else in 2 weeks and something else in 3 years. We are in a chemical soup. So he did modeling studies, and he lent me the next slide, and this modeling really shows that at very low levels, environmental estrogens can work together. And this is one of his slides from the talk he gave last year in New York City, and this is published work. He took 8 different environmental estrogens, and he took their levels, the amount, way, 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 way down in his test system, to the point that they were not estrogenic in the test system. Then he calculated mathematically, if I put them together, what kind of response should I get? If my hypothesis is correct, that they will work together and then have an estrogenic response. So the yellow bar is what he calculated, CA, the response to be. Red is what actually he saw. So he was able, with great accuracy, to predict that together, while singly they had no estrogenic effect, together they worked as environmental estrogens. And his work And the fact that the CDC is seeing we have widespread exposure in the biology was the reason we've gone forth with this project. And this, again, is what we're going to talk about for the rest of the talk. In your packets, you have 4 handouts, one for each topic of the video for plastic, cosmetics, and down the dump in the drain. And we also have a resource guide on alternatives and recycling. So if you're not able to stay with us to see the videos later this evening, the web address is at the bottom. And I want to commend a new staff person in BServe, Heather Stone, here, did all the work compiling all of our resource lists and doing much of the work on the development of all our graphics and working with our graphic designer. And Heather really hit the ground running, and it's been wonderful working with her. So let's talk about bisphenol A. We make a lot of it globally, 6 million pounds. In the US, we make 2.3 million pounds, and 60% of it is used in making polycarbonate plastics, and 40% is used in epoxy resins. In the plastics, it's useful because it's transparent, it's rigid, and it's resistant to breaking. And it is used in sports bottles, baby bottles, and to a lesser extent in food containers. It was really meant to be used first in the automobile industry. If you all go out to your cars and you look at what's covering your headlights, it's polycarbonate plastic. Optically clear, doesn't break easily. It's also used for safety equipment, bike helmets, safety goggles, ski goggles, and also it's used in all of your CDs and DVDs. So it has widespread application. The epoxy resins is mostly used to line the inside of food cans. And while some it's quite obvious, it's very white. In others, it looks kind of amber or gold. Others is orange. Other than one brand, Eden Foods, Eden Organics, that makes one of their beans, does not use the BPA epoxy resin. We have not been able to find a can yet that we've opened up that does not have a resin inside it. The key thing with BPA is it's released with heat. So when you buy the canned food, the BPA is already leached into the food. Doesn't matter what the shelf life is, it's the high heat canning process that releases BPA into the food. So we've seen low levels in a variety of canned foods, whether it be canned beans, vegetables, soup, pasta, tuna fish, evaporated milk, infant formula, and pet food. And to a lesser extent in soda cans, beer cans, and energy drinks. Most of the press has been looking at polycarbonate bottles and baby bottles, but in actuality, the largest exposure is from canned foods. The studies that have, and the studies for canned foods have been done all over the world, in Korea and Europe and the US, so we have a lot of data on the canned food. And the polycarbonate bottles, again, the key is heating. To a lesser extent, washing them and bottle brushing them and wear and tear does cause leaching over time. As the plastic ages and cracks and gets fissures and scratched, it's more liable to leach. But the key factor is really heat. And where does your kid's soccer bottle sit? In your back of your car on a nice hot summer day? We kind of abuse plastics a lot. We don't treat them gently the way it was intended. And so there have been studies where they've scientifically looked at polycarbonate sports bottles as well as baby bottles and have poured in hot liquids and have looked at leaching. A study from the University of Cincinnati found that a brand new polycarbonate bottle that nothing had ever been in before was really leaching almost nothing, really, really minimal. But after it had one use of a hot liquid, it kept on leaching even if the liquid in it was at room temperature. So just one heat cycle caused leaching to keep on occurring from the polycarbonate bottles. How do you know if a bottle is polycarbonate? When you flip it over, it should have a 7 in the recycle triangle and PC, the initials, to stand for polycarbonate. Sometimes it'll just say 7 and other. Doesn't always say polycarbonate. We don't have any information on leaching from everyone's water cooler jugs, those big light blue carboys. Again, it would depend on the treatment of it, and we do not have any published information on how it's stored, how they're disinfected and washed. So there would be the possibility, if they go through heat treatment, of leaching into the large polycarbonate water carboys. Dental sealants also use epoxies, and there actually are studies on it. And the suggestion is that you should spit a lot in the first hour after you have dental sealants put on. And that's like the only recommendation that's out there right now. What do we know about human exposure? This is one of the few cases that in Japan there was a lot of concern in the early 1990s, because in Japan then, 10 years ago, instead of drinking a lot of pop and soda, they drank canned coffee and canned tea in cans that used BPA in the epoxy. And they were detecting urinary levels of BPA in the college students. And Japan is very sensitive to environmental issues. Hue and cry went out. The formulation got changed. They remeasured the levels of the college students still drinking canned tea and canned coffee. And lo and behold, they were lower. So a change in formulation can change human exposure. But there has been no movement to change canning practices in the US because it's much more expensive. The one thing that works is kind of based on pine resins, and it costs 14% more to produce that kind of can than your traditional can. The EPA did studies of daycare centers in North Carolina, and they found BPA on the kids' hands, in beverages, and in food. So this is not a fly-by-night organization. This is a study done by the Environmental Protection Agency, because one of their labs is just down the road in North Carolina, right across from where I used to work at the National Institute of Environmental Health Sciences. Some of the newest data came out just several months ago, this spring, published again by the Center for Disease Control. They again used their survey. It's called the NHANES study, the National Health and Nutrition Examination Survey, and they analyzed over 2,500 urine samples, and they found BPA in over 92% of the samples. So we know that we have wide, low-level exposure to BPA in this country, and we probably aren't. It's not like other chemicals that we've dealt with in this group that are stored. It's pretty rapidly metabolized, so the fact that we found it in urine means we have a ubiquitous, constant exposure. So there's very little data of storage. There's just a little bit of data that small amounts might be stored, but by and large we do intake it and excrete it. So the fact that we found it ubiquitously means we are all getting exposed at some level. And we have found BPA in breast milk. And there is one study that, again, suggested some is stored. But by and large, we probably just have a low-level ubiquitous exposure. We also have a lot of controversies. For those of you following the press, the National Toxicology Program looked at BPA in terms of how it was affecting reproduction and development. So young age exposures, looking at human exposures in animal models. And they rated a variety of things. And for mammary gland, they based their work primarily on the work of Dr. Anna Soto at Tufts University, because she found at critical windows of exposure, BPA exposure in very young pups, did result in some changes in the development of the mammary gland. Again, the mammary gland, when you're born, it's like the size of your little fingernail. So it's not like your liver that you're born with. Your mammary gland grows in response to hormones. And she found in the rodent studies she did that the mammary gland development changed with a single BPA exposure. She used little mini osmotic pumps that she pumped it in. And she found some evidence that some of the lesions looked abnormal, and there was a lot of controversy of whether these hyperplastic lesions would or would not have the capacity of turning into full-blown breast tumors. So the concern was at some level, and it got reduced to minimal because of the controversy. I hope this just fuels more studies so we can know definitively what is the risk in regards to mammary gland development and later effects on tumor growth. There is currently a huge controversy with the Food and Drug Administration, who did make statements that current levels of exposure were not of concern. And just last Friday, a report was issued of another sub-panel within the FDA that critiqued the first report that the FDA had released, calling for the data to be reanalyzed. So there was a lot of controversy over how low-level exposures do affect health. And for many of the chemicals we're exposed to, sometimes, the absence of data doesn't mean there's an absence of risk. And it is always a moving target, and the FDA was criticized because they hadn't considered a lot of the more recent data in their analysis, and they're really being asked to examine it again. So what can you do now? Avoid heat and plastics. That's the big message. So don't leave it in your car. Please don't microwave in plastic. Use glass or lead-free ceramics, and that includes slitting those little steamer bags and dumping it into your Pyrex containers. If you do choose to use polycarbonate containers, you have to treat them gently so they don't have scratches and have BPA leaching. So if you do have a polycarbonate water bottle or baby bottle, you can't really use the bottle brushes on them. You have to hand wash them and not put them in the dishwasher if you don't want them to leach BPA. If you do have a polycarbonate water bottle and you want to get rid of it, please do not put it in the trash. Recycle it. At least in Ithaca, we're fortunate that our solid waste facility accepts polycarbonate bottles right into the recycling bin. Please call your local solid waste facility and find out, will they take them? Or, it makes a great penny jar. Use it for another use. I'm a firm believer in reuse. You can alternatively choose to get a BPA-free container, including, someone else held one up, a stainless steel water bottle. We are proud to say that we put posters up in the Cornell campus store at the beginning of October recommending that people have stainless steel water bottles. And we don't know if we had influence, but we do know that Cornell has now released a stainless steel water bottle that on the bottom is stamped BPA free. So maybe we had some success.
How much do they sell for?
I think like $12 or $13.
That's a bargain because they're usually 14 to 18.
Right. We would urge you to look for high-grade food quality containers. Some of these are being rapidly, now it's fashionable, so we're seeing a lot on the market. But try to look for stainless steel containers that are stainless steel in and out. Not necessarily plastic in the middle. This is stainless steel on the outside. I don't know what kind of plastic is on the inside. This is stainless steel in and out, high quality food grade stainless steel, and it was just at a big box store. So these are widely available.
Which Eden bean is the one that's safe?
It's only one, there's only one bean. It's just Eden Organic.
They have many beans. It's all beans.
All of their beans, right. Sorry. Did I go ahead?
Yes.
Sorry. Okay. So now we're switching to cosmetics. And there are three we wanted to talk about: UV screens, parabens, and placental-containing products. UV screens are not only used in sun protection products, but in many, many other cosmetics. And we've listed some on this slide, from fragrances, hairspray, shampoos, conditioners, styling gels, face creams, foundation, moisturizers, and lipstick, liquid hand soap, body wash, insect repellent, nail polish, and remover, and for the guys, shaving cream and aftershave. So we haven't left you out either. And the levels that they're in is fairly high, 2 to 15% per ingredient by weight. So you can have some cosmetic and personal care products that have several UV screens that are in there in the 5 to 15% by weight range, which means you can have some products that approach 50% by weight of UV screens. Very high amounts. And there have been studies showing that some of the most commonly used UV screens are absorbed within 1 hour of skin application. Parabens are used in very low amounts as preservatives, so only in 0.1 to 0.3%, so very low levels. They're the last ingredient on the ingredients, but they're used in tens of thousands of cosmetic products. Placental products are using animal placenta that have trace amounts of estrogen, and that estrogen is going to bind to the estrogen receptor and other stored hormones. There's very few products that are currently on the market, but they definitely have trace levels of these hormones. And this slide gives you an idea. We did searches on the Skin Deep Cosmetic Safety Database put out by the Environmental Working Group, and it is one of the tools you can use to look up products and see what the ingredients are, and look up these names to see if the product you're using or the product you would like to get doesn't have the environmental estrogens. But this gives you an idea of the number of products. For instance, for the UV screens, almost 5,000 products. For paraben-containing products, we're talking about tens of thousands of products. And some of these products have been found in sewage effluent. The parabens, even though in really low amounts, they've been detected in sewage effluent. We talked about water processing and water treatment plants in an earlier talk. So one study has found that these three very commonly used UV screens, so the 4-MBC is used in Europe and not in the US, in full body application studies at a 10% level, which would be reasonable. Many of these are used at that level. Appeared in the blood in 1 to 2 hours and were all detected in the urine, so they were all absorbed. And again, a study by the CDC done in March did find BP3 detected in 96.8% of the urine samples of over 2,500 Americans. Other UV screens have not been monitored by the CDC. Are there any that aren't estrogenic? There's only one that's been tested and does not test as being estrogenic, and it's called avobenzone. The other name in Europe is called Parasol 1789. What about the inorganic screens, the metals like zinc oxide and titanium dioxide? We have not been able to locate any studies that have tested their estrogenicity, so we don't know. They do indicate that these metals are not absorbed through the skin. We don't know, many of them are nano products, and we really don't have information either way, so we really don't know. We can't really make an assessment of risk. But my big message is, pale is the new thin. Tanning is terrible, and that's my quote. No one else said this. Everyone that knows me in B-Surf knows I take the bus to work, and I wear a hat, a straw hat. Actually, I have 6 of them, but those only go to church. But in any case, many dermatologists, including those at the Mayo Clinic in Scandinavia, has published papers in the Journal of American Medical Association really warning that we've so relied on this tanning culture and on sunscreens that we're just being exposed to way too much UV radiation. And even the FDA has said that if you rely only on sunscreen and do not cover up and do not go into the sun during the peak hours, there is no evidence that using sunscreen alone will protect against skin cancer. It's only one of the tools to protect you from the sun. And in fact, some people are concerned because exposure might have even gone greater because people are spending so much longer in the sun because they do have UV screens. So use it wisely, but minimize time in the sun. But look at all the other products that you may be using that are cosmetics that have UV screens, and we advise you to avoid those. Don't use UV screens to prolong time in the sun. Okay, so the third thing we want to talk about is what goes down the drain and in the dump. And we're going to talk about detergents and metals. Detergents. This is kind of a really odd thing, as we're talking about sewage again. But in actuality, things that get the dirt out have a name called surfactants. Okay? So the surfactants that we've been using for a long time have a really long chemical name, ethoxylated alkyl phenols. And it really is kind of this little ring structure, and it's got a big long tail. So it's got a ring structure and this big long tail at the top, and a little tail at the bottom. That compound is not estrogenic in the laundry detergent or in the dish soap or in your dishwashing soap. When it goes through sewage treatment has bacteria to break things down. That's what sewage treatment is supposed to do. Well, that little tail gets chewed up. Now it's got just a little hydroxyl group, this little phenol, and a little chain at the bottom. Now it's small enough to fit into the estrogen receptor, and it's estrogenic. So it's actually sewage treatment that makes a compound that was not toxic into a toxic compound. Household sources: laundry detergent, dishwashing detergent, carpet cleaners, and it's also found in personal care products, including some spermicides and vaginal creams, anti-jock itching cream, men's shavings cream, men's hair dyes, and eyeliner, and household paints. Industrially, it's added to pesticides as a dispersant. It's used in paper making, metalworking, wool cleaning, in industrial degreasing operations. So again, just to review, it's really the sewage treatment that results, and that's what it looks like. So it's a little ring structure, an OH on the top, and a little structure at the bottom, but what got chewed off was this really long chain. So what happens to it? It gets discharged from treatment plants and it ends up in sewage sludge. And we don't know a whole lot about what happens after that. We do know that sewage sludge is applied to agricultural land, and there is 1 or 2 studies in the UK that have found that low levels of nonylphenol have been detected at really low levels in sheep grazing on treated fields. We really have very little data, so we really can't say if it's in livestock. We really don't know. But we do know worldwide nonylphenol is detected in rivers from China to Detroit. So we have wide, ubiquitous exposure. So what did Europe do? They banned it. So in 2005, the UK started banning it earlier than that. They started using it in laundry detergents in the 1970s, but they kept on using it industrially, especially to do things like clean wool. And this is another case where the first harmful effect was detected in fish. So UK researchers put cages of fish where the sewage effluent was coming out into the rivers, and did find that the male fish were turning into female fish, the juvenile younger fish. And based on its widespread detection, on its endocrine disrupting effects, its effects on wildlife, and concern of getting to the human food supply, in 2005 the European Union banned the manufacture and the use of these ethoxylated nonylphenols and nonylphenol itself. In the US, the FDA regulates its use in cosmetics, and there's been no ban of it. The Environmental Protection Agency does not regulate the ethoxylated compound or nonylphenol in every product, in any product. It does acknowledge its toxicity to aquatic organisms and fish. It has started something called the Safer Surfactant Stewardship Initiative that will recognize companies that voluntarily use a safer surfactant in their product. But we have no regulation. So what can you do now? You can use Environmental Working Group Skin Deep database to identify products with non-oxal 9, which is the nonylphenol in cosmetics. For laundry detergents and dish detergents, read the label. Try to choose products that list all the ingredients. Unlike cosmetics, where the ingredients are required to be listed, in cleaning products, we do not have right-to-know consumer laws. And as advocates here, I think that's something you should really consider. How do you make a choice when there's no requirement that it has to be listed on labels? So look at those companies that do put the ingredients on the labels and choose those that are biodegradable and that use plant-based surfactants. Coconut is probably the most commonly used. The good news is when we started this project, you couldn't go to any mainline grocery store and find any of these products. And that has changed in just, not because of us, but it's changed in the last 6 months. Why? Because companies have the European Union ruling and they're not going to make something they can sell here in Europe. They're going to have to sell it in Europe, so they're going to make one product, which means they're going to change their formulation. So not only do green brands are now sold in mainline grocery stores, but many other companies, mainline companies, are making much more environmentally friendly detergents. And part of the resource list you have mentions the names of, and some of the handouts you have mention some of those brands. Lastly, something you might not have heard of is that estrogenic heavy metals and electronics. And we have evidence from laboratory animal and tissue culture studies and one study in humans. So we don't have a lot of human data, admittedly. We need more studies to look at this. One study at the University of Wisconsin did find that breast cancer risk was 2-fold higher in women that had higher urinary levels of cadmium. One study does not show causation, so it's just an association, but it's a heads up that we need more data. The e-waste crisis is dramatic. When I talk to sororities, I say, once that cell phone was fashionable. Not anymore. Is it in the dump? Is it in the trash? Is it in your back drawer? Is it on your closet shelf? In 2005, the EPA estimated that Americans discarded 2 million tons of electronic waste, and much of it had heavy metals, with over 80% to 95% ending up in the landfill, and that we still have 180 million old cell phones and old fax machines and everything else sitting in our households and businesses. The plus is a lot of it is due with older products. So it's the older rechargeable cell phones that have the nickel cadmium batteries. The newer ones do not have the batteries with cadmium anymore. For TV screens, a lot of people are replacing their TVs to now get the plasma screens and the big screen TVs. And if you've got a husband like mine that likes sports, we now have the thing in the basement. But old TV screens, the older ones used 7 pounds of lead to line the screen. Newer ones, the glass ones, around 2 pounds. So what you can do is really, the EPA has a great website to help find ways to reuse, recover, and recycle. And it really is connecting people with the businesses. Many of the businesses that make the electronics will take the product back, will take the cell phones back. It's a great website, and it gives you lots of ideas of ways to deal with your products. So with everything I've talked about today, we've turned what you've heard into short videos on cosmetics, plastics, and in the dump and down the drain. Really short. And we really want you to share these not only with the advocacy community, but with your daughters and your granddaughters and high schoolers and college students. Not only do we have them here, but we also have them on our website. My parting words: a decrease in exposure to many estrogenic chemicals that are in widespread use, even if a single chemical's health risk is low, can translate into the prevention of breast cancer or at least a delay in the development of the disease. And I'd like to thank very much the people that funded our project. We have a contract with the New York State Department of Health and got extra T there, Department of Environmental Conservation. And these are all the people that worked on this project, and they deserve applause too. We've been working on this for 14 months.